Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Deep beneath the crushing weight of the midnight zone, thousands of meters below the ocean's surface, a silent revolution is brewing. This isn't a revolution of silicon or cooling fans, but one of organic light and chemical signals. We are entering the era of the bioluminescent ledger. As our global digital infrastructure groans under the weight of massive energy consumption and the looming threat of quantum decryption, scientists are looking to one of Earth's oldest survival mechanisms to save the future of data: the glowing communication of deep-sea bacteria. To understand why we need a biological alternative, we first have to look at the problem with our current gold standard, the blockchain. While blockchain technology is revolutionary for its decentralization, it has two massive Achilles heels. First, the proof of work required to secure traditional blockchains like Bitcoin consumes more electricity than entire nations. Second, as quantum computers become a reality, the mathematical puzzles that protect our digital ledgers are becoming increasingly vulnerable. We need a system that is complex, energy efficient, and physically impossible to replicate from a distance. Enter the deep-sea microbes. In the darkness of the abyss, organisms like Vibrio fischeri use a process called quorum sensing. This is essentially a biological consensus algorithm. These bacteria release signaling molecules into their environment. Only when the concentration of these molecules reaches a specific threshold, indicating a quorum, or a majority of the population, do the bacteria simultaneously trigger their bioluminescence. This all-or-nothing switch is remarkably similar to how nodes on a blockchain must agree before a transaction is validated. However, instead of using trillions of calculations per second, these bacteria use the fundamental laws of chemistry and fluid dynamics. So, how does this become a bioluminescent ledger? Researchers are proposing a system where data is not stored in bits and bytes on a hard drive, but in the genetic sequences and metabolic states of bacterial colonies. This is known as DNA data storage, which is already a proven concept. DNA is millions of times more dense than any flash drive, capable of storing every bit of data humanity has ever produced in a space no larger than a shoebox. But the bioluminescent ledger takes it a step further by using the bacteria's light-producing capabilities as an encryption key. Imagine a secure transaction where the private key is not a string of numbers, but a specific chemical signature or a sequence of light pulses from a living colony. To hack this ledger, an intruder wouldn't just need to break a code. They would need to physically replicate the exact biological state of a living organism, including its unique epigenetic markers and the chaotic, nonlinear way it responds to environmental stimuli. This creates a biological firewall that is virtually impossible to bypass using traditional digital methods. Furthermore, these biological systems are incredibly energy efficient. While a data center requires megawatts of power to stay cool, a colony of deep-sea bacteria operates at the ambient temperature of the ocean, fueled by simple organic nutrients. The mining process in this ledger would be the natural growth and replication of the bacteria. As the colony grows, it replicates the ledger, creating a decentralized network that is quite literally alive. If one part of the colony is compromised, the chemical signals of the surrounding bacteria would detect the anomaly, much like a white blood cell attacking a virus, and isolate the corrupted node from the rest of the light-emitting network. We are already seeing the first steps toward this living internet. Scientists have successfully encoded short GIFs and text files into the DNA of E. coli, and others have developed biocryptography protocols that use fluorescent proteins to hide messages. By moving these experiments to deep-sea extremophiles, which are adapted to survive in the harshest conditions on the planet, we create a ledger that is not only secure but also incredibly durable. These bacteria can survive pressures that would crush a submarine, making them the perfect guardians for our most sensitive information. As we look toward a future where our digital lives are increasingly under threat, the answer may lie in the cold, glowing depths of our own planet. The bioluminescent ledger represents a bridge between the digital and the organic, reminding us that nature has spent billions of years perfecting the art of secure, efficient communication. The next time you see a photo of a glowing deep-sea creature, remember, you might be looking at the future of the global economy. For more incredible facts like this, don't forget to subscribe and turn on notifications.